Good morning, everybody. Today is Monday, September 9th, 2024, and we are working through writing pseudocode and doing problems by hand with temperature conversions, with the end result of writing a MATLAB program that will automate this calculation for us. So everything that we're doing is working toward that goal. Now, today we're going to meet both today in lecture here at 9 o'clock, and then we'll meet again in lab this afternoon. And that will also be on Zoom, but I don't record the whole lab periods because they tend to be, well, it's not like a lecture where we're talking every minute. A lot of it is just people working on stuff on their own time. But right now, what we should have done, you should have completed the temperature conversion problems, and I will grade those later today. If you submitted them early, I did grade them, but if you submitted them by Friday, I'll get them graded today. And if not, please get them done as soon as possible because we need to make sure that I get everything graded. If you don't get it, so the way that I usually work this is I wait a day or two past the due date for a homework assignment and I grade. And if you don't have it turned in by that time, you get a 0 in the grade book. So if you get it caught up before the next assignment, you still have, I'll go back when I grade the second assignment, for example, and I'll check to see if anybody submitted, and I'll give you a grade at that point. But it's important that you not be very far behind. A day or two or a little bit is fine. But basically you need to make sure that you stay on track with the class or the work isn't going to make that much sense to you, because everything in engineering in general builds on everything else that you've ever done, as I'm sure Oz would attest to you, based on dynamics, right? You're supposed to know, you're supposed to remember and recall every single thing that you have ever studied and pull it together and be coherent, and that's a difficult task. All right, so by today, in lab today, we're going to work on sections 6 through 10, or if you're done by that, that would be super. And then we'll finish off or attempt to get finished off with the MATLAB onboarding by the end of this week. So the assignment that's coming due for Wednesday is to write pseudocode for the temperature conversion assignment. And we've discussed this a little bit, what the purpose of writing pseudocode is and what pseudocode itself is. Now, the other thing is I will be opening up some more stuff this week, but this is what's going to be required of you by the end of this week. So in other words, everything that's required to be done by the end of this week is already open. Okay, so the next thing that will be due next Monday, which will be the completion of the MATLAB onboarding. So, and then I'll show you what to submit when we get all completed, because we really haven't had an assignment for sections 1 through 5 or 6 through 10, except for just me working with you a little bit. But there will be, there's a certificate of completion that I'll show to you in lab today, and you need to submit that. It will show me that you've done all the work. Okay. So one of the things that we talked about with pseudocode is what we're really doing is laying out the basis for an algorithm for how you are going to execute a problem. And we do that in pseudocode at an English, because we're all English speakers mostly, an English language level. In other words, we are not computer language specific at this time. This is just a very complete step-by-step of how the problem is going to be solved. Because what happens, the good news and the bad news about writing a computer program, the good news is it will automate what you tell it to do. The bad news is it will automate what you tell it to do. So if you tell it the wrong thing, it will automate the wrong thing, and it will do it forever and ever. So there's an old expression in computer programming. We're going to talk about some sort of historic computer programming algorithmic ideas, but GIGO just stands for garbage in, garbage out. So if you write a bad program, it will do what you tell it to forever and ever and ever. So what we want to do with pseudocode is write a good program that does what you say. That does what you want, not what you say. We'll always do what you say. That does what you want. Okay. So basically, let's talk a little bit about temperature conversions. Okay, so some of this is going to be the basis of the pseudocode that you're going to be writing, but I'm not going to obviously write out the whole thing for you. But basically in temperature conversions, what you want to do is accept user input. So in other words, the user, who's going to be you most of the time, but it could be someone else in a truly automated format, will put in a number, which is the degree, and then the scale, right? So you need to have a way to say to the user, what is the temperature? And maybe it's, you know, input, accept input, maybe 45 degrees centigrade or negative 65 degrees Fahrenheit or something like this. So you have to have two inputs, and you can do that in one step or you can do that in two steps. So in other words, you can ask the user, what is your temperature and what degree units is it in? Or you can do that in two separate steps. I would suggest it's much easier to do it in two separate steps. Okay. Then the next thing you have to do is to make a decision, which is, well, I'm writing really tiny today for some reason. All right, the decision is if. An if statement is a big programming loop, which you're going to encounter if you haven't already with MATLAB, but every programming language that I am aware of will always allow you to make a decision. So if, for example, you enter in degrees Fahrenheit, then you would calculate degrees Rankine, degrees Kelvin, and degrees centigrade and degrees Kelvin. Else if, which I'll just put if here because it's different code for different things. If you input stuff in degrees R, you would calculate in degrees Fahrenheit, degrees Celsius, and degrees Kelvin, and etc. Right? So there's four choices at that decision loop based on the degrees that the temperature is entered in. All right. Now the next part is temperature cannot be less than absolute zero. It just can't. Why is that? Because it is a physical impossibility. So this is one of the places where you have to make a decision again based on the physical reality, not on the math. The math will calculate this for you if it is below absolute zero, but it doesn't make any sense. And returning a value is not effective, is not accurate at that point. So you need to do another decision if the temp is less than absolute zero. You don't need to output the number. You need to output something like invalid input or error in input or something like that. But basically, you can also tell it, you might tell if you wish, you could say, try again. And then you need to loop back up to the beginning and ask for a different input. Okay. If that doesn't happen, you need to output or print. And there's a bunch of different commands that will print in MATLAB. Something like whatever I input, negative 65 degrees Fahrenheit, for example, is the same as X number of degrees Celsius, X number of degrees Rankine, X number of degrees Kelvin. And at that point, you end the program. Okay, so what I've done here is not like what you're going to turn in exactly, but this is the nature of pseudocode. And pseudocode is a slightly less structured way of writing what is called a flow chart. And a flow chart is a very structured way of saying what I'm going to write. So, like I said earlier, the purpose of a pseudocode or a flow chart is to very carefully analyze what it is you want this program to do, and then write out those steps pre-language, pre-computer language, in order to execute it properly every single time. So trial and error is part of this process. And I was talking with one of my colleagues who teaches computer science over at Sheridan College. He's a guy named Mark Toney, very intelligent person. But one of the other teachers in the room asked, how can you tell if someone's cheating? How can you tell if somebody uses AI or if somebody copies somebody else's program? And Mark said very correctly that a computer program is really like a signature. In other words, there are 10,000 ways in MATLAB to get from one point to the other. And if somebody has exactly the same way of getting from one point to the other as someone else, they didn't write it. The other thing is, because it's an iterative process, you're going to be at this for a while, right? So you're not going to have just one iteration where you put everything in and it's gorgeous and it works perfectly. It just doesn't work that way. So, and like I said, there's a lot, there used to be an old commercial where they said there's a lot of ways you can eat a Reese's. There's a lot of ways that you can do this kind of stuff. So it's very important that your code reflects the process, but it's also very important for you to realize that there's way more than one way for you to do this. Okay, and one example that I would suggest that I did when I was in college way back when, which might be, maybe I wouldn't say it was cheating, but I would say perhaps it was a way around a confounding problem that I had. So when I was in college, we were programming in environments like this, but my teacher had programmed back in the days when they used punch cards. And if anybody's ever seen a punch card for a computer, what it basically is a card like about this big, and you would type things in and it would punch out little holes in it, and that would be a single line of code. Well, I am not a good typist, and this was a problem for me. So a computer program would be a stack of cards like this. And I mean, a little tiny program. So my professor made us do a punch card program just because he felt like it was elegant and that's how he learned and blah, blah, blah. So I was troubled by this possibility. And so what I actually did was I wrote the program and I compiled it the way that we're doing it today in the programming environment. And once it worked, I put it on punch cards because then I knew it worked, right? So I eliminated everything except my own lack of typing skills and put it into the system. But that was like, and then what I'm saying is it allowed me to do my punch cards in one single iteration. You never get anything in one single iteration unless you're doing something like that. So, so there's a lot of different ways that this can be. So if you two are working together, for example, not that you have to, but I'm just saying if you two are working together and your code looks different than your code, that's to be expected. I mean, there are going to be certain things that are going to be the same, obviously, but there's a lot of different variety for how this works. The other thing is, I haven't tested it this year. I tested last year. I used Gemini, which used to be Bard AI, to write computer code. Failed miserably. It just did not compile, which means it didn't work. So it created something that looked like code. I put it into the MATLAB environment and it just blew up. So keep that in mind as well. You can use it as a starting point. I mean, it's fine with me if you use it as a starting point if you want to. But please rest assured that you're still going to be, in the mud with the code before it's all over. All right. So those are just some ideas about computer programming. So let's talk a little bit then about what is the big deal about a flow chart. Well, like I said, a flow chart is like an ultra structured type of a pseudocode. It has its own symbols, it has its own ideas about what to do, or not what to do, but it spells out explicitly what happens. So what I have done is I have brought up 3 different flow charts that were written by different students last year. And I brought up good ones, by the way. These are all really, really good. There was a lot of good ones, but these were 3 that I thought were good and also different enough that I would like to show you what this is. Now, I have never had my ES 1060 students do flow charts. It's beyond the scope. I'm just showing you this as what you're getting at with pseudocode, okay? This was written by a computer science 1010 student, but basically, what he says is you start the project, which is indicated with an oval, and then you do some conversions, Celsius, Fahrenheit, Fahrenheit, Celsius. So this is not really complete, right? But then you do pseudocode, you create variables, you open for if else statements, which are those decision statements I was talking about. You test to make sure that you're not going below absolute 0. And if it is below absolute 0, you do one thing. And if it's not, then you do another thing and you close the if statement. And then you display, so you have some prompts, you have some inputs, you have a decision, you have the end of the project. This is really good code for a computer programmer, but it doesn't get down into the dirt about the exact steps that you need to take. So it's good code, but it's not really going to accomplish every single thing that I would like it to accomplish. Okay, here's one. Let me come up here and zoom on it. That is a little closer to what I had in mind, but basically, let's see. I want to see if it's going to let me. So tiny. Let's just take a look here. So we start the program, you input type, what it asks for numbers 1 through 4. And I bring this up because instead of typing in, so you'll get into this with MATLAB. The way that this student solved a very seemingly easy, but really turned out to be a crazy bad, difficult problem, is if you ask for input, you say you want it in degrees Fahrenheit or Rankine, and you type in F or R, it comes out as something called a string variable, and they're very picky. And MATLAB has a harder time digesting that than they do numbers. So this student said, if you're going to input your number in Fahrenheit, enter 1. If you're going to enter your stuff in Rankine, enter 2. And it worked really well because 1, 2, 3, and 4 are not string variables, they're numeric variables, and MATLAB handles those better. So you don't have to do it. Once again, this is another thing where it's a signature, right? So instead of messing with this piece for a few days, he just cut right to it. You got that piece of it out of the way right away. All right, so then it accepts that, and then you make a decision. It takes that type, and then you have to put in a number. And if you have an input is 1 or an input is 2, input is 3 or 4, so in other words, maybe Fahrenheit, Celsius, Rankine, Kelvin, it makes these other, it calculates the other ones based on that. All right. Now, if everything is above 0, then you can end the program. But after you do those things, you have to check to see if it puts anything below absolute 0. And if it does, you're going to have a different kind of an output, which is invalid output. Okay. So these 2 students built their flow charts in Excel, which is really kind of clever. I don't know that it's necessary. So I wanted to show you another one where a student just did it by hand and did a beautiful job, by the way. So let's go ahead and share this screen. So basically, we input the temperature, this student input it as a number or as a letter, C, F, K, or R. So if it's not no, it came back up and says input. So if you entered Q or you entered Fred, it said, no, try again, right? So that was another clever thing, because otherwise your program will just blow up and it will give you some weird error message, you know? But basically, this restricted the input to one of those four things. It also solved, not as well, but it solved that problem of a string variable, because even if you put in like small c and it only wanted a capital C, it would kick you back up. So it would give you a clue right there that you did something incorrect. So that was a nice little thing. All right. So then if you get that in C, F, K, or R, then it does these calculations. Now she didn't do all of the calculations here. Or maybe she did this in a strange way. It was a really good program. I shouldn't say strange, but I mean, it's just a little bit different. So it took those numbers and then it tested to make sure at that point, you see, she's testing right away if it's going below absolute zero. So if it goes below absolute zero, she's not going to display anything. She just kicks you back up again. So, but then if it is not below absolute zero, then it does these calculations. And this calculation just takes it and calculates it in one other set of numbers. It doesn't do all of the numbers. So in other words, I want you to calculate all three. So in other words, if it inputs an F, you need to calculate C, K, and R. Okay, but so the structure is still the same. So flowcharts are kind of elegant in the sense that it's all spelled out and you can see. It's like, I don't know, if anybody's a musician, it's kind of like reading music. You know what I mean? I mean, like you can see all the stuff before you actually hear it. So that's kind of a cool thing. Yeah.
So when you put that in your code, just like it, so it makes it look like that.
It does not look like that. It's going to look like whatever it looks like in a MATLAB environment. So this is pre-code. So in other words, a flow chart just tells you what you're going to do. Then you have to use the language, in our case, MATLAB, to program in that language. Yeah, but this is just that structure. So what I'm emphasizing is you have to do the structure before you, if you start, and that's why I brought up the thing about the punch cards from back in the day, because if you try to do stuff just on the fly, like, you know, you are just gonna make yourself very unhappy. So the more pre-work you do before you actually start coding, the better off you're going to be. The more you understand what the problem is and what you want that computer program to do, the better off you're going to be. All right. So do you guys have any questions about that? Well, like I said, the good news is, I don't know if it's good news or not, I think it's kind of good news. You're not going to have to write a flow chart. The flow chart kind of shows you. So pseudocode is sort of like a less structured method of getting from what you want it to do mathematically to what the computer programming environment will do for you. And that's what we're doing with flow charting, or with, excuse me, oh my gosh, with pseudocode. All right. Wants me to save this because I rotated it so that we didn't have to look at it sideways. All right. So do you guys have any questions about this so far? Do you have any questions about the temperature conversion problems, the homework? No, you're all good. All right. So I would offer to you the idea that if you're committed to using strings in MATLAB, definitely do something to limit the input on the string. If you want to use numbers, it's a really cool, efficient, it's almost like a bypass of a whole bunch of stuff that MATLAB has trouble doing. Now, that's another good point too, is that other languages handle strings much better. MATLAB has, I don't know how to put it. There are some computer programming languages that require structured, more or less structured input, and MATLAB does not require structured input or formatted input, but it does, because it was written as a mathematical language for engineers to solve arrays. It doesn't handle letters or strings very well. It really loves numbers. So the quicker you can get to a number with MATLAB, the better you are. And that's not the case for every programming language. So that's kind of the upshot of what's going on with that. All right. So having said that, let's take a look at a couple of other things on our Moodle page, which I'll put up here. and we'll see where we're gonna go. Now, like I said last time, I'm only gonna have you write 2 programs in MATLAB, and then we're gonna get to Excel. So it's only gonna be a few more weeks 2 or 3 more weeks, before we're finished with our MATLAB extravaganza. But, the one, after we get done, well, we're gonna be working on these simultaneously because the second program that I'm introducing is actually going to be a lot easier to write than this program. This is sort of like the culmination of our efforts with MATLAB. But this little graphic shows what's called a tech stack. And I think that this is something that is not really obvious. Whenever you turn on your computer, maybe it's obvious, maybe it's not obvious, I don't know. But basically, every time that you work on anything on a personal computer, all of these things are different levels of tech, and any one of them can get you hung up. But basically, the operating system, which for us here is Windows, is at the bottom of this tech stack. And I just thought it was really interesting to think about this, because if you see where the programming language exists, it's pretty far up. So even though it looks like you're in a standalone situation, you really have 1, 2, 3, 4 levels of tech below what you're doing when you start working in MATLAB or whatever language you happen to be working in. So that's just an important consideration. But when you get in that programming language, everything else kind of has to work. And a very obvious example of this is, like I had said earlier, when you're programming, the way that I test your code is to put it in my programming environment and to see if it works. And if it doesn't work, or if it works incorrectly, to identify where those gaps are. So you can't, for example, send me a picture of your code, because I can't work with that. Otherwise, I would have to type it back in. If I have to type back in, then first of all, it's going to take me a long time. And second of all, there's a lot of room for my errors. So that's why I need to have it in something that I can pull directly into that programming language. So the other thing that I want to show you just really quickly is what the second program is. And this goes into another feature of sort of like the history of programming. So this will be available to you later on today. But basically, so, structured programming in general, computer programming in general started quite a long time ago. But the first history of modern-ish computer programming was after World War II, or during World War II in the late 1940s. And all language was machine language at that point. And to be honest, from what I've read historically, I mean, I feel like I've been alive forever, but I was not alive at that time. I don't really have any personal knowledge of it, but people employed rooms full of people who were called computer programmers. So a computer program was not something that was like this. And basically, everything was machine language. So everything was talking in zeros and ones to a big overheating system at all times. But originally, people would take pieces of code, and the big deal computer programmers were trying to do ballistics calculations. That was kind of the first big group of stuff that became popular with computers, because there's a lot of repetitive calculations in ballistics, as you may know if you've had physics 1, for example. But anyway, they basically used like wires with connectors on them. They put them in 1 or 0 holes in order to make everything work. Well, because of that, that's when I looked at that tech stack. Obviously, the tech stack on something like that is way different. What is your tech stack? Your tech stack is this big room full, this big wall of things that you're going to be plugging cords into and speaking to it in machine language. Well, so you can also see why, even though from my generation of people, using punch cards was an incredible backward movement, you can see that when you've been plugging wires into boards, that a punch card probably looked like some pretty significant tech improvement at that point. Anyway, so the whole thing has evolved, but so there's a lot of history and just a lot of tradition involved in working with computers. So a Hello World program is just something that it's sort of like it's a tradition that computer programmers use. So the first thing that is typically used when a program launches is just the computer waking up, the tech stack coming up, then the language, the environment, just saying hello world. Okay, and it just means like it's just an acknowledgement that what you're working with is hardware and you're turning it into something forward looking. Instead of just being a bunch of ones and zeros and electrical impulses, you're doing something forward looking and something that interfaces with a human being. And so that's where the Hello World program comes up. But it's very traditional to write Hello World programs with anything that you start. So we're just going to write a little Hello World program. And I think you'll find it interesting. There's some stuff about it specifically, but that will be one of your assignments. So we'll do 2 programs. We'll do the Hello World, which is just turning on the computer, getting it to say hello world, and moving forward from there. And then we'll do the temperature conversion program. And then in about 2 weeks, we'll be done with that and we'll get back into MATLAB. So, all right. So at this point, do we have any questions or comments? You guys are gonna take it too easy on me. It was way different. I taught this class last year with 2 classes at the same time and about 20 people. So things were a lot more time consuming than when it's just 3 or 4 of us. So absolutely. And we'll be together this afternoon at 3. So we'll definitely get going on that. So good. Okay, well, good then. That'll be awesome. But so we'll do Hello World and we'll do temp conversion. And then after that, we'll probably have some sort of an assessment. I don't know what that's going to look like, but we'll figure it out at that point. And then we'll get right into Excel, which is going to be the main computing tool. All right.
Are we doing this today? All that today?
No, this is over the next couple weeks. Yep. Yeah. So we're going to finish off the onboarding first so that you have that basis for discussion so that we can, because yeah, you know, that's another thing too. And different instructors have different philosophies about this, but I really feel like there's this instructional technique called scaffolding, which means you sort of have to build on every step. So if you don't have the steps in the beginning, even if they seem obvious to most people, some people just miss something somewhere along the way. So if you don't know how to do the basics of computer programming, you're not gonna be able to do anything else. So I feel like we should scaffold this quite nicely, start at the bottom and make sure that all the rungs on the ladder are sufficiently covered before we move forward. So how's that sound? So I keep telling you, it's a weird way to present this though, because it's like I keep telling you where we're going to go, how everything's going to tie in, because I think at the beginning it seems like there's just like, and then we're going to do pseudocode, and then there's a program, and then there's blah, 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 blah. It just seems kind of all over the place. But I promise it's all tying together into this beautiful mosaic of programming in MATLAB and programming in general, which is the other part. So that when you go somewhere and you have Visual Basic, or you have Python, or you have whatever program your employer throws at you, you're going to be able to cope with that on a more basic level than just coding. All right. All right. Well, that's it for today. I'm going to go ahead and stop recording, and I'll put this up on our Moodle page, and then I will see you guys at is it 3 or 2 o'clock that we meet this afternoon? Is it 2? Okay. Yeah. It's 2 o'clock for 3 hours. Is it 3 o'clock for 2 hours, or is it 2 o'clock for 3 hours?
I think it's
2 o'clock for as much as 3 hours. We don't have to be there 3 hours, but. All right. All right. So I'll see you this afternoon then.
From 2 to 3:40.
Oh, I have it down from 2 to 5. So it's from 2 to 3:40, even better. All right. We'll see you guys at 2 o'clock this afternoon. Sounds good.